This movie will guide you through the steps required to reduce and plot USANS data. To start a USANS reduction session, select from the Macros menu, Load NCNR USANS Reduction Macros. The procedures will compile, and you'll be presented with a main USANS control panel. The first thing to do is set the data path. In this case, sample data is included within the package you downloaded in the SANS Utilities folder, Sample Data folder, USANS, Raw Data. Select this folder, and while we're here, we can go ahead and set the save path where the reduced files will be written out to the same folder. Refresh the listing of files. The first files on the list here are, starting with CU, these are copper samples, and as we scroll through them, we see them update. The monitor counts at the top, transmission counts, and detector counts. The last few files here, CU EMP, are empty, and you can see the first one goes through the main beam, and then the other two are at higher angles. So if we select those three files, move them to the empty, and plot them, and the first 5 files, which are different angular ranges measured for the copper sample, move them to the sample scans, plot them. We see the graph here. We can clear this. And we can see that they've been aligned to 0 angle at the peak. We see that the empty scattering is measured over a truncated range, so we can simply manually increase this level to somewhat extrapolate the level of the empty beam, which becomes flat very quickly, and raise the background level to an appropriate value. This is old data, so these values are somewhat artificial. The values that are currently default in the package are current values for what is measured at the instrument. So the first thing to do is, after adjusting those, is to update the transmission values. This measures a ratio of the rocking transmission, which is through the primary beam, and the wide-angle transmission, which is out at angles greater than about 2 degrees. Typically this ratio should be less than about 90%. If it's not, a red warning flag will show up here, indicating that more than 10% of your beam is being scattered coherently. At this point, you should talk to your local contact because you may have too much multiple scattering in your data. You'd set the sample thickness, and then the final thing to do is correct the data set. You can also change the logarithmic scaling on the x-axis. It highlights the data somewhat better. The upper curve here is the corrected data that the empty and background have been subtracted, and this is now converted onto absolute scale. The last thing to do is save the data. We typically don't want to keep this lowest Q data through the primary beam, so we put the cursors on and move the cursors to about somewhere around 3 times 10 to the minus 5 is about the lowest Q values you'll be able to resolve. Depending on the scattering from your sample, you may not get quite that low. In this case, there is a significant difference. There's more than an order of magnitude of difference in the sample scattering and the empty scattering, so it's a safe subtraction. If we click on Save Data, we'll be prompted for a save name. In this case, we'll just call this copper, and COR stands for core or corrected data. This is actually slit smeared data, and X stands for XML data format. Now that you've corrected your data, you'd like to see it on a plot by itself without all the other bits that have been subtracted from your data. To do this, from the USANS menu, select Load USANS Data. Select the file that we just saved from the dialog and click Open. At this point, you're presented with a dialog to extrapolate the slope to higher Q. Click on Calculate. It extrapolates the slope, and then when you click Accept Slope, this will calculate a resolution smearing matrix. This will take a few seconds to do this, but the payoff will come later when you do resolution smeared fitting to your data. So here's our data with the low Q points trimmed off and neatly plotted. Again, this is resolution smeared data. One thing you can do with resolution smeared data is desmear the data, although I don't recommend this. It can be done really for visualization purposes. To desmear data, select Desmear USANS Data from the USANS menu. And then we'll follow left to right through the tabs at the top of the panel. We'll load the data by picking the data file as before. This file has already been loaded, so no, we don't need to reload it again. Next step is to mask out any extraneous data points. In this case, we can mask out a few of the data points at the upper end, but this is typically not necessary. We do need to do the extrapolation. This is an integral part of the desmearing operation. Typically do not smooth the data, and then finally desmear the data. This takes a few seconds. It's an iterative process, but very quickly converges to a solution, and the upper curve here in blue is your desmeared data. We can then save this data file, and typically a DSM for desmeared is appended to the file name with an X as the extension, indicating this XML data. The next thing we'd like to do with the data is, of course, fit the data. So we can hide the USANS macros and show the analysis macros. Our copper data has already been loaded. What we'd like to do is add a model function. In this case, spheres with a log normal size distribution would be appropriate. Once this loads, we can, with the plot manager, regraph data that we have previously loaded, and then plot a smeared log normal sphere function against the copper slit smeared data, and then append the data to the graph. Parameters are shown in the table below. Of course, we'll need something much larger for the radius. You do not know the scattering length density of the solvent, or the sphere in this case. We do want to hold the background fixed at 0. At this point, we can simply do the fit. I'd like to save the report to see the results of the fit. Fit converges very quickly, missing somewhat at the higher Q values, but provides a very good fit to the data. At this point, given that you know more about the sample, you could apply a better model or refine the parameters of the fit.